Let us make this program in codices. I have already made here set reset. You see, from I0 positive pulse M0, from M0 we have taken set from 1 to 9. Correct? From 1, 2, 3, 4, 5, 6, 7, 8, 9. Set. For reset, I have taken percentage IX 0.1, positive pulse, M10, MX 0.10, 0.10. So from this, we have taken reset ladder 1 to 9. Here you see 1 to 9. I shall show you here move instruction from M1. Let me take percentage M1. Sorry. It will be a problem. Okay. From M1, we have to take a move instruction. Move instruction we have to take by right click, add object, box with en, right click, box with en, enable. Here we have to type MOVE, move. Okay. Click outside, two sides, two parameters, left and right. Left side we have to give the value. Can you text me the value, please? 3. You please text me, next time. So it is 3. Very first, it is 3. Just a minute. So 3 we have to move here, percentage QB0 to QB0, percentage QB0, 0 I have not taken. Let me take 0. It is done. So when M1 gets set, this value will be moved. Now we copy this and we paste it here. Now from M1, M2, the value is, text me the value please, next value. Okay, I have it in my phone. 109. 109. Again, paste. From M3, we have to move. It is 103. 103. Yes, 103. Correct. Now copy paste. From M4, we have to move 83. Okay. Now from M5, we have to move 118. 118. From 7, from 8. So 127. 127. Now from M9, last one. After that, 0 will be left. So from M9, we have to move the value 119. 119. Fine. It is done. Now I shall show you this thing in visualization because there only we can check. Add object. Okay. So we have to take here segment. I take here this rectangle. Okay. And to this rectangle, let us give the color. Let me give it black only, black. And when it is on, we shall make it red. Okay. When will it get changed? When percentage QX 0.0 will get high. So this will get red. Okay. Now we do copy paste, control C V. So it would be 1. So when 0.1 is high, this will get on. The same thing we want here, control C V. But we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now let me take this here. It would be wider. Color black, after on red, and output variable percentage QX 0.6. Now control CV. Two. 0, 1, 2, 3, 4, 5. We will have to take this. 5 and 6 we have already taken. I think we will have to make some gap here also, like this. Okay, so 7 segments we have taken here. Now let us take button for increment. Percentage IX 0.0. Input tap variable percentage IX 0.0. Now we need one more here. We need one more. Line width, color, variable percentage, ix 0.1, input tab variable, percentage ix 0.1. Okay, so we take it here. So we have two switches, one for increment, one for decrement. Let us see whether it works or not. Login and run. 0 we have not added yet. 0 we have not added. Further I will show you 0. First, without 0 I want to check. So when we press it first time, so you see 1 is displayed, right? 1 is displayed. When you press this, it will go back. It should go back, but it is not going, you see. When you press I1, it is not going back. It is a problem. Let us check. So when you press I1, what is the status of M1? M1 is off. M1 is off. But the value is okay. But the value is 3 returned. So last value is still retained. So it won't go below 1. So minimum 1 it will show you. I will tell you what I want to say. See, it will go up to 3, 4, 5, 6, 7, 8, 9. Okay, 9, right? After that, it can go to 8, 7, 6, 5, 4, 3, 2, 1. Below 1 it won't go. Okay, because below 1 means everything should get off. So below 1 it won't go. We will do that. If you want to remove this 0 also, then lastly you will have to move 0. Move 0. Then these two will get off. What happens? Lastly, you see, when you came back, lastly 3 is retained. Once one value is gone, will be retained until you make it 0. So if you want to remove this one display also, then 0 you will have to move 0 to QB0. Then everything will be off lastly. Okay. Now let us add 0 display. 0 display. But before that, it is not that interesting display. Color. Let me remove. I go to color and initial color I remove. Invisible I should make. Color gone. Color gone. Or we have other option also, we will see further. Color gone. Color gone. Okay. If I do it now, what happens? Let us check. 1, 2, correct. 3, 4, It will come back also, but it will be minimum 1. Now let us add 0 display also. 0 display. For 0 display, what have I done? From M1 NC, I have moved. Let us see whether it works or not. Control C, B. From M1 NC, because 1 will come initially when we press. We make it NC. And 63, when you calculate, how will you calculate? You see, except this Q6, all should get on, right? Q0 to Q6, Q5, 1, 0, 1, 2, 3, 4, 5. This we have not to get on. So it will make a 0 display. For that, Q6 you leave, other you have to add. So 32, 16, 8, 4, 2, 1, if you add, I think it will come 63. So we need to display 0 by moving 63 to QB0. So as you log in and run, directly supply will reach and 63 will be moved. So initially it will show you that 0 display. Let us see whether it works or not. So here I do login, run, and you see initially as you do login run, 0 will be displayed. Now you go 1 and come back. It will come to 0. 1, 0. So 2, 3, 4, 5, 6, 7, 8, 9. After 9, it won't go more. It will come back. Got it. I hope you understand. Done. I'll share this program with you. What other thing I wanted to do was like, okay, let it be. This is good. But let me group this or else it will be scattered. So we can right click and make it a group. Now it will be a single unit. You can move anywhere. Okay, this I will send you. Text me if you have any question. It is better to see the things in video because showing you through the laptop camera will not be that clear. So I have recorded it. See, these are the outputs, indicators. We have already discussed that 24-volt DC outputs can be directly connected to PLC. So these are the 24-volt DC operated indicators we have connected to PLC. Connection already I have told you in wiring session. Wiring is easy. The diagram you can see once more if you have confusion. Further you can see that. Then you see here, these are the sensors I have connected. This is a photo sensor, light emitting sensor. These two are metal detector. Here is the push button, green color, red color for start and stop. This is SMPS, switch mode power supply for 24 volt DC. I had told you we need SMPS for wiring. This is SMPS 24 volt DC. We give it 230 volt and it gives us 24 volt DC. Then you see this is the PLC. Just a minute. It is better I keep this on top because it disturbs a lot. Okay, let me go back here. Okay, after SMPS, you see we have here PLC, programmable logic controller. This is the PLC. Still it is not that clear. Okay, so this is the PLC. This side Mitsubishi PLC. This is Mitsubishi FX2N PLC. It has 32 inputs here, 32 outputs here, 32 input terminals, 32 output terminals. On this PLC, you can see you have input indicator. Like if any input is on, if I press push button, then if push button is connected and PLC is getting signal, then indicator will get on. If sensor is on, then respective indicator on PLC will get on. So PLC will show you on indicator which input is on, which is off. And these are the output indicators. Inside program, when any output gets on, inside program, when any output coil gets on, then respective output indicator will be on. See, these are the input terminals. Here it is not that clear. It is X0, X1, X2, X3. It is written like that. I shall make some more videos more clear. So these are the input terminals. This is the communication port. On this PLC here we have RS422, RS422 8 pin, RS422 8 pin communication port. And this is the cable for Mitsubishi. This can be used for Mitsubishi only. These are the outputs. So you see Y. Can you see Y? Y5. Here it is Y0, Y1, Y2, Y3 like that. Y10, Y11, Y13, Y12. So these are the output terminals. Here we have output terminals. This is a VFD, variable frequency drive to control the parameter of motor, to control the parameters of motor. We can control direction, we can control speed, we can control acceleration time, detortion time. Many parameters related to motor can be controlled, or you can say all parameters related to motor can be controlled by VFD. So from PLC, we are sending command to VFD and VFD will control the motor. So here you see to this VFD, one motor is connected. Here, this motor is connected. First, let me show you how do we make program in Mitsubishi software, that is GX Developer or GX Works. Then we will come back to this again. So we open GX Developer. See, here is GX Developer software for Mitsubishi. I click this. and let it be any brand of PLC. Working process will be the same almost. You have seen when you get the data about Mitsubishi, you made program yourself. It is not difficult. So when you work on Allen Bradley or Siemens or Delta, you just collect its input output address and the syntax of timer counter and all. It is easy to make program for any brand. So this is GX developer. Very first we take a new file. In new file you see in Mitsubishi, these are the CPUs. This is the series. So you have Q CPU, in Q CPU, Q mode, A mode. I had told QNA CPU, A CPU, right? Motion CPU is for, you can say motion control, that is for robotics, for axis control. Motion CPU is used for axis control basically. FX CPU, just now I have shown you Mitsubishi FX2N PLC. So it is of FX series. So we click it FX CPU, we will click this. And you see you have CNC also. For Mitsubishi, you have CNC also. For CNC also, they have a particular controller that is CNC M6, M7. Our PLC is FX series. In FX also you have these many types, models. Even you see, if I click Q, CPU Q mode, it has also many types, you see, it has many types. So like that in FX, our is FX series. In FX, ours is FX2N, FX2N. Okay. Just a minute. So FX2N we have selected, ladder is already selected. We make it okay. Usually it does not take this much time. Because of Zoom, it is taking time. So this is the ladder opened. Here we need to take our NO and C coil, whatever we have in our logic. In 1 minute, the session will expire. Again, we will log in and then I will continue with the same. So here I take NO. When you take NO, you have to give address, like you know it is X0. So you have to give X0 here. Again, it went. Working just now. Okay, so X0 we have taken like this. If you want NC, you click this and you take X1 if you want, X1 for stop. For coil, you see, you have coil here, F7, M0, enter. So like this, one ladder will be made. If you want parallel connection, then don't click here, click down. New ladder will come automatically.